All right, today we're going to pull back the curtain on the digital world and really get into how the software we use every single day gets made. And let me tell you, it's often this wild journey from, total chaos to that clean functional code we all love. I mean, who hasn't, right? You're just going about your day and bam, this amazing idea for an app hits you. Something that could totally change the game, make your life easier, or just be a ton of fun. You can just picture it. But then you hit the wall, the reality check. Because let's be real, turning that brilliant idea into actual working software, it's a whole other ballgame. It is way more than just slinging some code together. It's a minefield of challenges. And this right here, this is what we call the chaos problem. It's the fundamental challenge of building anything. Think about it. Your future user, they probably only have a fuzzy idea of what they want. The plan you start with, oh, it's going to change, trust me. And all the while, you're trying to build these massive, complex systems. It is a constant battle. So how in the world do you fight all that chaos? Well, you fight it with a plan. And that's exactly what software engineering is all about. It's the framework, the secret sauce for bringing some order to all that madness. Okay, so first things first, what even is software? It's not just the code, right? It's the whole shebang. It's the instructions that run on the computer, it's how the data is organized, and this part is so important, it's all the documents that tell you how to actually use the thing. And that brings us to software engineering. See, this isn't just about hacking some code together. It's a discipline. It's about taking a systematic, measurable approach to building things. I love this analogy. It's the difference between knocking together a backyard shed and engineering a massive skyscraper. So no matter what you're building, pretty much every project goes through these same basic steps. You got to have a plan, right? Figure out the time, the money, the tech. Then you define exactly what it needs to do. Then you design the blueprint. Then you write the code, and you're not done. You have to test the heck out of it to find all the bugs. And even after it's out in the world, the work continues. It's a whole life cycle. Okay, so to manage all those steps, developers use what are called process models. Honestly, the best way to think about them is like recipes for building software. So let's start with some of the classics, the old school recipes that are super strict and step by step. And first up is the granddaddy of them all, the waterfall model. It really is the original recipe. And the logic is super simple. You do one step, you finish it completely, and only then do you move to the next one. Planning? Done. Now design? Done. Now coding? It all just flows down in one direction. Kind of like a waterfall. Now, you can't just use this recipe for everything. Waterfall can be great for smaller projects where you know exactly what you want right from day one. But, and this is a huge but, its biggest weakness is that it's so rigid. Imagine you're almost done in the testing phase and you find a major flaw in the original design. Uh-oh. Going back up the waterfall? It's practically impossible, or at the very least, crazy expensive. And that right there is the problem, isn't it? This quote just nails it. Real projects are messy. They never follow a perfect, straight line, and it's almost impossible to know everything you'll need at the very beginning. And that's why this whole rigid approach pushed people to find better, more flexible ways to build things. And that leads us right into a new generation of models. These were literally invented to deal with that chaos problem we started with. They're all about adapting to change instead of fighting it. Just look at the difference here. It's night and day. Waterfall is all about follow the plan no matter what, and you get one big delivery at the very, very end. Agile, on the other hand, says change is good, let's welcome it. The whole point is to deliver working software all the time in little bite-sized pieces. It's a huge mental shift. Now, in this newer family of models, you've got this really interesting one called the spiral model. It's kind of a hybrid. It's iterative, but its number one focus, its obsession, really, is risk. With every single loop of the spiral, the very first thing the team does is stop and ask, what could go wrong here? Then they figure out how to deal with it. This one's important, so remember it. All right, enough theory. Let's make this real. Imagine we're building a brand new mobile banking app. I mean, the stakes don't get much higher than people's money, right? So which recipe are we going to use? Okay, before we pick our model, we got to know our priorities. For a banking app, security has to be rock solid, non-negotiable. We've got tons of regulations to follow. Risk is a huge deal. But at the same time, we need to get it to market fast and get feedback from our actual customers so we can keep improving it. That's a lot to juggle. So how do we make the call? Well, remember that spiral model? The one obsessed with risk? That looks like a really good fit here. Agile is also a great option, especially for getting those new features out quickly and listening to users. You might even look at something like the V model, which is all about intense testing. But waterfall? Probably not. Banking rules can change in a heartbeat, so a rigid plan would be a disaster. So what's the big takeaway here after looking at all these different ways to build software? It's pretty simple, actually. There is no one-size-fits-all answer. There's no single best way to do things. Look, the mark of a truly great software engineer isn't just about how well they can write code. It's about being a strategist. It's about looking at a problem, really understanding it, and then deliberately choosing the perfect recipe for that specific job to get it done right. So I'll leave you with this. The next time you're using your favorite app, just pause for a second and think, what recipe do you think they used to build this thing? Was it a strict step-by-step plan, or did they build it piece by piece, adapting as they went? Pretty cool to think about, right? Thanks for tuning in.